Good morning, everyone. I'm Mark Pullen, the Innovations and Training Director for TÜV SÜD Dunbar Boardman, and today I'm going to give you a brief overview of our predictive maintenance system, Lift Manager. So here we can see some of the building owner and lift contractor pains with the historic approach to the maintenance project and some of the Lift Manager benefits. So traditionally, the building owners have high maintenance costs, a low quality or an inferior service, no transparency in the information shared with their maintenance company, and the unpredictability of breakdowns. From the industry point of view, there is a lack of trained staff, an aging workforce, and the need for increased efficiencies, and also to embrace new regulations and technologies. So how can the Lift Manager system assist both the client and the contractor? We can ensure that there are optimized maintenance costs, improved availability of the lift equipment, and a 24/7 real-time transparency on the performance of the lifts. From the contractor point of view, there's an oversight on the lift performance prior to the maintenance activities. This can highlight any troublesome areas, particularly with doors or leveling performance, before the engineer arrives on site. And also, there's a potential to reduce the maintenance frequency from a historical monthly maintenance. We could go to bi-monthly or quarterly via the use of the data, or in the ultimate aim would be to go on-demand maintenance that is driven by the data. So the system uses Bosch IOT sensors, and there are three sensor units that are mounted on the car top. The car top main sensor, the door sensor, and the laser rangefinder. The main sensor has 8 sensors inbuilt within the unit. There's the 3-axis accelerometer, a gyroscope, a magnetometer, a humidity sensor, pressure sensor, temperature sensor, acoustics, and a light sensor. The door sensor basically uses a 3-axis accelerometer and a magnetometer, and the laser rangefinder is used to give an indication of the floor leveling accuracy of the lift. So, hands up who's wearing a smartwatch or an iPhone to monitor their steps and biometrics. We're seeing data used widely across all industries and applications. Many people using the likes of Strava to monitor their training performances. So imagine doing the same thing with your lift systems by using IoT sensors. So what can we derive from these sensors? We can derive speed, acceleration and jerk, the ride quality in the 3-axis, in the X, Y and Z axis. Because we've got the light sensor and the speed sensor, we can determine that there is maintenance activity in the shaft. Hopefully the engineer has switched the shaft lights on to do the maintenance, and then because they're traveling intermittent speeds, slow speeds down the shaft, then we can determine that there is a maintenance activity being undertaken. From the acoustic sensor and the pressure sensor, we can deduce that there's been an activity on the alarm button and that the lift has stopped mid-floors. So again, we can pick up that there's a man trap situation. From the door sensor, we can derive the opening and closing speeds and door vibration, and also detect any abnormal door operations. The sensor data is fed via the cloud into our AI analytic modules, and this is where we can provide anomaly detection and predictive component failure information on the client user interface. Our system is brand agnostic and can be fitted to any type or age of lift. The system is non-invasive and does not connect to the control system in any way. This has the advantage that there is no cybersecurity risk where an attack can compromise the safe operation of the lift. At best, the hacker will only be able to see the raw data from the sensors. As you can see, the system has been retrofitted to a widespread of manufacturers' equipment. So here's a flow chart of our predictive maintenance system Lift Manager. The key points from the slides are: one, the fault tree library on the left, which was compiled by our data and lift experts. Two, the primary data from the Bosch sensors. Three, our analytics and domain knowledge to make sense of the data based on our 80 years industry experience. So what is an anomaly? An anomaly can be likened to a person with a fever. Where their temperature rises above 37 degrees, the anomaly would be detected. The predictive element could be the continuous monitoring of someone's blood pressure, and an increasing trend could indicate that a person is suffering from hypertension. So if we use the same analogies within the lift, then we can monitor for anomalies. These could be poor ride quality or door performance. But if we trend the information over a period of time, we can see a deterioration in the performance signatures, and this can lead us to give a prediction on future failures. So here we have an overview of the system architecture. On the left are the IOT sensors and gateway that are mounted on the lift car. The Microsoft Azure cloud that is operated by Bosch, utilizing our analytics predictive maintenance engine, and the user interface that is used to display the lift performance data and historical data that can be shared with the OEM and the client. This shows real-time anomaly detection, historical events and trends, and also predictive maintenance alerts that we put onto the system. So for the last 30 years or so, the industry has been using telemonitoring to provide feedback on the operational status of equipment. These telemonitoring systems are reactive systems, as any change of status only occurs following an event or an error. For instance, is the lift going up or going down? Are the doors open or closed? Or perhaps the power supply has failed, etc. The industry game changer is to use stream sensor data to analyse any signature changes that can indicate future failures or a point where the lift performance may fall below acceptable levels. The remaining time to downtime can also be ranked in order of severity, allowing building owners and their maintenance providers to plan our recommended corrective actions to mitigate a disruption to the building operations. So one of the key benefits of our Lift Manager solution is to ensure the reliability and safety of the lift by detecting and predicting hazards before they become an issue to passengers. We can tell if the maintenance is adequate based on usage levels and the performance signatures of the lift. Based on real-time data collection for the lift operations, we can alert any anomalies or upcoming failures to prevent a breakdown or inferior performance. For instance, we can track floor leveling errors via the rangefinder to prevent slips and trips should the leveling start to deviate beyond acceptable levels. All lift data is collected and displayed on a single user interface. It is possible to display the data on any other user interface system via an appropriate application program interface. Anomalies and predictive information can also be issued via email or SMS text messages. So on the economic side, the solution will also be able to provide and reduce maintenance costs and increase the lifespan of the lift through early detection of faults, which can minimise the stress on connected components. For basic type contracts, there will be a direct saving, preventing failures, and also the rejection of quotes for unnecessary renewals or repairs that may have been recommended by the lift maintenance company. For comprehensive contracts, these could change to have a performance-based arrangement with KPIs. For instance, for undertaking predictive works before failures occur or before poor performance occurs. Components will be changed based on their performance as opposed to the OEM's current run-till-fail approach as seen on many comprehensive contracts. Data built up over a period of time can also be used to highlight underperforming brands or design to better enable future planning of asset renewals. So this is our vision of future lift maintenance with the deployment of IoT sensors and machine learning techniques. And how can we move away from the historical way of working? So we can go from a time-based regime to an on-demand maintenance regime. Typically, maintenance activities are on a checklist-based regime. We can go to a data-driven regime. Parts procurement is ad hoc. By using the data, we can perhaps plan parts acquisition via the data. If we can see that there is a trend for components to wear, then they can be ordered before they fail. And we can go from a fixed rate maintenance contract to a performance-based maintenance contract. So that's the overview of our Lift Manager predictive maintenance system. I hope the information presented is useful. However, I want to emphasise 3 key points in summary. We are a trusted partner, independent of any lift manufacturer. IoT sensors and machine learning will be at the forefront of future industrial and commercial operations. And Lift Manager can assist building owners in the management of their lift portfolios in a safer and more cost-effective way. Thank you for the opportunity to allow me to showcase our Lift Manager system. And now I'll hand over to Paul for the Q&A session.
Thank you, Mark. Let's run through some of the questions we've received. What is the solution able to achieve so far? Like the accuracy and also improvement to breakdown rates, and what is the return of investment, ROI, for the solution?
On current projects, we've achieved an 80% accuracy in predicting failures. This has reduced the failure rate by between 10 and 15% on the historical breakdown history. For the return of investment, then as we mentioned, there's a potential to go from a monthly regime to maybe a bi-monthly or quarterly regime by using the data to sort of analyse the performance or the continuous performance of the lift operations, with the aim to go to an on-demand maintenance system in the future, very similar to what the automotive industry is doing. So yeah, that's the sort of game changer with using the IoT technologies.
Okay, thank you, Mark. If retrofitted, how does the system know, for example, what the original starts per hour versus its current usage levels journey counter to see if the PPM should be adjusted accordingly?
We also use secondary data. It's important to get a feel for the lift's history, but obviously the system can detect the lift movement and the usage levels So then this is the part of our domain knowledge. We would advise a client on a strategy based on the performance and the usage levels. So this may give you an opportunity to look at each individual lift on its own merits and tailor the maintenance to the lift's requirement, rather than just having a broad brush monthly or bi-monthly approach. And it may be that as buildings come back into use, that again, being data driven, that some lifts may historically have been very busy, but are lightly used. So yeah, it would be a sort of on demand and a maintenance reaction to the usage levels.
I've got another question here. Thank you, Mark. Until today, I thought that TÜV SÜD is just making sure solutions of others are operating within certain parameters or cannot harm persons, etc. This seems to be a solution for a particular problem. Is the TÜV selling the solution to elevator operators?
The lift manager system is open for building owners and for lift contractors. So yeah, it's brand agnostic or lift agnostic system that can be retrofitted to any lift. So whether it be the building owner or the lift contractor, many of our projects, the building owner actually shares the data and access to the user interface to their maintenance provider. So we want to work hand in glove with the building owner and their maintenance provider to get a better outcome and drive maintenance standards higher.
Thank you. Another question here. Did you encounter problems during the field test when it comes to mount the laser on the lift roof and receiving the reflected signal back? Do you use a reflector plate?
This has been an issue. Typically the Bosch laser performance is 150 meters, but depending on the slab construction, then particularly on the higher rise, 100 meters plus, then we may introduce a reflective service to get the laser bounce to adequate level, so that the system can read the distance.
Perfect. Thanks, Mark. Another question here. How is the information displayed in the dashboard? How simple is it to understand and use?
We've tried to make it as simplistic as possible, but again, because there's a basic screen that sort of gives you the lift operational statistics, door timing, number of travels, etc. But you can dig down. It's on a menu-based system, so you can track down into the lift's history, and then we also flag up corrective actions, the anomaly detection. We will give you maybe 3 or 4 or 5 possible causes, and maybe 5 recommended actions that are displayed on the screen. So if there's an anomaly detected, maybe the door performance at one floor has been an issue, then it could possibly be that there's debris in the track, or the door drive belt or the door motor is an issue. So there are three or 4 possibilities that are given the anomaly, and then we would also point the technician or the client in the direction of giving some recommended actions. So it could be check the door tracks, check the drive belts that they're not worn, and check the functionality of the door motor to make sure there's no problem there. So yeah, there's an overview screen that shows the anomalies and the possibilities and corrective actions, and then also there'll be an RTD time. Again, that's traffic light, so you may find that if the leveling accuracy is starting to deviate, it would flag it up to be checked on the next maintenance visit. But if it goes above a certain threshold, say 10 millimeters, then that becomes an immediate RTD, because obviously there's a trip hazard to the user.
Thank you, Mark, for that. I've got another question here. Every lift manager uses different components for their elevator, where LifeScan can be different. How does your system analyze and carry out predictive maintenance?
Well, we're using our 80 years of domain expertise, so we will sort of create the digital twin and look at the performance of all the metadata that's streamed back from each individual lift. Obviously, with it being brand agnostic, it can fit to machine roomless lifts. It can fit to sort of 30, 40-year-old two-speed AC or single speed lifts. So each lift has its own particular characteristics. So then we would tune the digital twin. Ultimately, we don't want to create lots of false positives and flag out issues that aren't actually issues. It could be just that particular brand or age. It's just the quirky behaviour that's particular to that type of lift or that particular installation. So there is some tuning that can be done within the algorithms to make sure that we don't flag out things that aren't an issue.
Perfect, thanks, Mark. Another one here. What do you detect with the audio sensor?
Yeah, the audio sensor is basically a pure acoustic. It's not any frequency or so basically, because the sensor is mounted on the car top, we'd usually ensure that there's an alarm sounder or an alarm bell that's close by, so we can pick up the signature or the decibel intensity of that particular bell or sounder. So coupled with the fact that we know that the lift's not at floor level, then if somebody's pressing the alarm bell, it suggests that there's a man trap situation.
Another one here. Do you feel the big players within the lift industry who have their own systems, Otis, REM, would benefit for this system as an addition, or do you see this replacement to their current system fitted?
I believe that our solution, being brand agnostic, it can fit to any lift. From what I've seen of the OEM solutions, it's only fitted to that particular brand. So from a client's point of view, if they've got a lot of different brand types on their portfolio, and they want to go with sort of Otis or Schindler or whoever it may be, then they may have to have several different user interfaces. So it's sort of combining all this information from various manufacturers onto one system. That's the beauty of Lift Manager, is that it's brand agnostic. It's non-invasive. It doesn't connect to the control panel, so it can be retrofitted to any lift. And again, from what I've seen of other systems, it's all about sharing the data. We're truly open. The data isn't our data; it's the client's data, and it's for them to share it. So, on previous projects, current projects, the client is actually sharing the access to the user interface with their maintenance provider. And there was a little bit of apprehension and kickback from the industry on these projects, but in the main, once they were familiarised with the systems and the technicians were using the data, they could see that it was a benefit to them as well. As I mentioned in some of the slides, that there's a lack of resource out there. So if they can use the data to better mobilise their responses and activities, then it's a win-win for everybody.
Thank you, Mark. Do you need engineers from Liftmakers to provide any technical specification to the system?
Not particularly, no. Some countries, some domains do require that the maintenance provider provides attendances for the installation, but in the main, no. We've got a good strength of lift expertise within the company, certainly within Dunbar Boardman and in Munich and further afield in Singapore. That our domain knowledge is strong, so we can look at any particular lift or brand on its own merits and fit the sensors appropriately, so they don't compromise the operation of the lift.
Another one here. How do you use secondary data like fault diagnostics, data service visits, etc., which is available in ERP of the lift company? How does this tie up with the AI algorithm?
Yeah, so that's an important part. Is that these are secondary data. It's not totally necessary, but it gives you like a closed loop process. So if we see an inferior or a declining signature in the performance of a piece of equipment, and we flag out an RTD time, say 2 weeks, then after the 2 weeks period, a maintenance activity has been undertaken, and the lift maintenance company has embraced the recommendations that we put on their user interface. Then, if they've done some corrective actions and repaired or adjusted the equipment, and the signature improves, then that is the sort of secondary data that's fed back into the AI, and it learns from that experience. It's a supervised system basically. So it doesn't necessarily need the secondary information, but it's like a closed loop. If we see some maintenance activity and the signature is improved, then we can deduce that that the lift maintenance company has undertaken the corrective actions that we recommended.
I think we would have the last question here. There's quite a few here we haven't got around to, but we can answer those offline. I'm sure Mark will be able to get in contact with you, and you'll get this slide deck after the webinar. The last one is the lift critical parts life cycle built in the predicted algorithm, or is this an option available to build up?
That would come with looking at a wide range of lifts operating in a similar environment. Eventually, the machine learning would pick up these critical failures, and again, that's the strength of TÜV SÜD, is that we've 80 years in the industry, and we undertake in excess of 300,000 inspections per annum. So our experts can feed back and advise our data analysts to make sense of some of the data. The more complex it is, then there needs to be a little thought process, and what we're seeing maybe on other sites that don't have Lift Manager, we're using our combined inspection suite to enhance the AI modules.
Thank you, Mark. Thanks. I'll close this webinar now. So thanks again for joining us. I'm sure you'll agree this is a great innovation, will save lots of time and money. As mentioned earlier, we are sending you a copy of the presentation and recording. We do have another real estate webinar, which is on the 26th of May, which is focusing on firefighting lifts. If you'd like to register on that, you can visit our website. Please get in touch if there's any other questions you'd like, or any other webinars you feel there'd be a topic that would be interesting for you to hear about. And also feel free to ask any questions of myself or Mark via the usual channels. On behalf of myself and the presenters, thank you for your time, and enjoy the rest of your day. Thank you.